Hello everyone, today I want to present our scientific paper with the title Finding Anomalies in the Time Series Data by using the wave equivalence method. Let's talk a bit about the authors. It is me, Yuri Hodlevskyi. I'm a PhD student of software engineering in Zhytomyr Polytechnic State University, and Vakaliuk is Doctor of Science, Professor and Head of the Department of Software Engineering, also in Zhytomyr Polytechnic State University. Let's talk a bit about our problem which we're solving. Imagine that we can have some factory. Inside this factory we can have some multiple equipments, and inside every equipment we can have difficult and different sensors which is returning the data to some applications. This data can have very different shapes, but today we discuss the problem of finding anomalies is inside wave-like data, when we have a data that can have a shape like waves. And into this screenshot you can see some regular waves. You can also notice that almost every of this wave is equal to the others. And we need to find anomalies, and we specify 4 main type of anomalies for this specific case. First type of anomaly, when the wave is wider. Second one is when the wave is narrower. The third one, it is a higher wave than others. And the fourth is when the wave is lower than other waves. And we need to find, specify and signalize to operator when we can found these waves. But how we can do it? First of all, we need to split up our waves, and after this check the equivalence of these waves. But first problem, how we can specify the wave. And our proposal, we can connect every point of data with the line and calculate a derivative for this line. In fact, it's a slope, and in fact it's a tangent for this alpha. And in this case we can understand when exactly wave grows, when the wave isn't changing, and when the wave is falling down. You can see inside this graphic, it is a graphic of a derivative, and it is clear that when a derivative of slope of this line is is bigger than 0, the wave is growing up. When the wave isn't changing, the derivative is equal to 0, and the wave falls when the derivative is less than 0. And we can go inside a loop, save all the information about every wave, and by using some statistical method we can calculate the mean and mode of these waves. Also we can play around where we should use mean, where we should use mode, but in our case we propose to use a mean for the width and mode for the height of the waves. And after all these calculations we can understand that, for example, in our case the normal width for the wave it is a 4, and the normal height for the wave it is a 3. After this we also proposing to have some coefficient for acceptable percentage of an error to make bigger or less our acceptable criteria for normal waves. And in this case we can have some more flexible algorithm to check the wave equivalence. And after all this calculation we can specify some anomalies data. Let's check the results. You can see that under red line we can have a width error, width anomaly, and under the blue one we can have a height anomaly. And these results prove that our algorithm is working. And thanks for your attention.